Action 1, Inspiring Action.
Look up, because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action 1 Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. You know, all that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me. And I feel like Action 1 Media's goal is aligned with mine. So together, we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community. Tune in to SG2 on Space on Thursdays at 8 p.m. U.S. Central Time. Look up, because you never know what you will see. Okay. All right, everybody. This is your host, Shen Ge. You're listening to SG2 on Space, episode number 37. You can follow me at facebook.com/The Shen Show, spelled THESHENSHOW. Here in the lovely studio of Action 1 Media Group, as you can see behind me as always. And Action 1 Media, you can go to weareA1.com. And for SG2 on Space, you can find us, you can find me on YouTube. So you can do a search for SG2 on Space every Thursday night live at 8 p.m. Houston Central Time. So, as noted, this is episode number 37. Today, I would like to talk about stars, rather strange stars. But before we talk about that, let me just mention that there's a lot of things going on right now, celebrating the 50th anniversary of Apollo, particularly Apollo 11, right? So Apollo 11, as you know, was the first, when humankind first landed on the moon. All right, and that was on July 20th, 1969 at 2017 Universal Time. So July 20th, that's coming up pretty soon if you're listening to this, live around this time, right? So there's a bunch of events going on all over the country. If you want to get more details, you can definitely go to nasa.gov/specials/Apollo 50th with a TH /events.html. But let me just highlight a few. All right. So on Friday, July 19th, at 1 p.m., NASA TV is going to broadcast. So you can watch on the NASA live page. So they're going to be NASA's going to be broadcasting live from the Kennedy Space Center in Florida. There's a newly restored Apollo Mission Control Room as well at Johnson Space Center, and as well at the Marshall Space Flight Center in Huntsville, Alabama. So there's going to be a couple of NASA centers, as well as the Smithsonian National Air and Space Museum in Washington. That's going to be part of this live broadcast, right? Okay. So from July 1st to October 5th, in Cambridge, Massachusetts, which is pretty close to, MIT and all that. This is particular at Draper. There's going to be called Hack the Moon Live Exhibit and Museum of the Moon. So this is quite a while. So, you can go to, it opens on, there's a couple that opens on July 21st. But anyways, you can check out Draper, and that will be on there. So in New York, at the Met, the Metropolitan Museum, in New York City, from July 3rd to September 22nd, there's a special exhibit called Apollo's Muse, the Moon in the Age of Photography, which basically presents visual representation of the moon from the dawn of photography through the present, which is beautiful. I hope they have some photos that the astronauts took while they were on the moon. That'd be cool. On July 11th, there's at Huntsville, Alabama, there's an Apollo propulsion and engines panel discussion. So this is a more technical in nature, but if you're going to be in Huntsville, Alabama, or you live there, why not, right? Then I found this interesting. On July 12th, there's an astronaut golf tournament in Orlando. Okay, speeding up here. Let's see. Anything else? There's actually ones for walking pub crawl. July 12th. Yeah, so you can go drink with astronauts. Amazing. This is also in Florida. On July 13th, Dr. Buzz Aldrin, second man on the moon, he's hosting a gala to commemorate the 50th anniversary of the Apollo 11 moon landing mission at the Ronald Reagan Presidential Library in Simi Valley, California. So, all right. And then there's a bunch more. So let me just stop right here, because then otherwise the whole show would be talking about Apollo 50th anniversaries. So yeah, definitely you guys see what you can do. If you're in Houston, there's a number of events as well, and I'll make sure to post it up on SG2 on Space, the Facebook page, so you guys are kept up to date. So, any case, since we started a bit later, I figure we'd just jump right in. So, in any case, today I want to talk about pulsars quite a bit, and so there's a nice little video. Okay, well, actually, before I talk about pulsars, let's talk about another star, and then we're going to take a break, and then we can talk about pulsars and such. Okay, so there's a star called Eta Carinae. I don't know if I'm never saying these Latin names right. Never took Latin, but whatever. Probably for the best. But anyways, so humanity started the relationship with this star back in 1838. All right, which is amazing, right? I mean, actually, no, there's some stars that people have seen for thousands of years. But this star, why? Because it suddenly brightened its, it basically exploded, okay? So it was so bright that for a time, it was basically the second brightest star in the sky. Second only to Sirius. Sirius was still number one. So, essentially, if you realize, actually, this star is 7,500 light years away, all right? So what we saw, the explosion, actually happened 7,500 light years, not light years, 7,500 years ago. So that's how long it took the light to come here, right? So this is a binary star system, and at least a binary star system, and 1844 may have been one of its final death throes. So it's basically going to die, all right? So we're watching a star that we're basically watching it die, and so this eruption 150 years ago almost destroyed the larger star. There's probably going to be even more that's coming up. Now, the reason I bring this up is because, okay, we've known this star for a while. It looks cool, What's so important? Well, there's been a new technique with imagery where we've used ultraviolet light to search for warm gas. And it turns out that we can use this technique to find new detail in objects we've previously studied. So, for instance, some researchers, quoting them, here's what they said. We had used Hubble, so the Hubble telescope, right, for decades to study Eta Carinae in visible and infrared light, and we thought we had a pretty good account of its ejected debris. But this new ultraviolet light image looks astonishingly different, revealing gas we did not see in either visible light or infrared images. We're excited by the prospect that this type of ultraviolet magnetism emission may also expose previously hidden gas in other types of objects that eject material, such as protostars or other dying stars, and only Hubble can take these kinds of pictures. Okay, hopefully James Webb goes up there soon and fulfills its destiny as well. The next stage past Hubble, right? Um, so yeah, this is really interesting because there's still a lot of mystery surrounding Eta Carinae. For instance, astronomers don't know what triggered that what's now termed the Great Eruption, 150 years ago, right? So one theory is that the double star system is actually a triple star system to begin with. And according to this theory, there's 3 stars, and say call it A, B, and C. So A and B were the 2 larger stars, and C was a smaller and orbited. So A and B here, C orbits it from a greater distance. A is the most massive, and near the end of the life, it began to swell. So it's like a balloon, right? It began to swell, and it dumped a lot of its materials. I wish I had a balloon. That'd be nice. It dumped a lot of its material into B, since B is so close to it, right? After feeding the material from A, B bulked up to about 100 solar masses, all right, and it became extremely bright. A, in the meantime, was stripped of its outer hydrogen layer, leaving only a helium core. So all of this mass transfer changed the gravitational balance of the system. So A moved away from, A was this one, right? So A moved away from its companion, okay? So A moved away. And once that happened, A and the smaller C that was out here got caught up gravitationally. Then A moved outward while C was drawn inward. And then star C was pulled gravitationally by B. Oh, wow. This seems so complicated. But it's cool. And then it was stripped of its outer material, which then formed. So star C's outer material stripped due to B. And then that formed a disk of material around C. Then B consumed the tiny C, which caused the Great Eruption. And then, hence, sending as much as 10 times the mass of our sun blasting into space, okay, forming what we now see as this nebula structure. All right, and then that left A, which, remember, was the instigator of this whole thing. Then A went into elongated orbit, and every 5.5 years, it passes through B. This is B's outer envelope, which creates shock waves that we see in X-ray. Phew. All right. So, if I had a whiteboard and balloons, this would have been much easier, but hopefully you guys get what I mean. So, eventually, according to astronomers, we all have this consensus that this star will end its beautiful display of fireworks with a final showstopper, which is a supernova. And that's going to outshine pretty much anything in the sky, except our sun. So when is this going to happen? Who knows? It probably already happened. It's just taking light, 7,500 years to get here. So the star may already be dead, all of them. These 3 stars. Well, 2. So with that, let's take a little break. When we come back, let's talk about pulsars, what they are, talk about the NICER telescope, talk about fast radio bursts, and a new topic I just found, talking about the Chinese telescope that's supposed to detect them. We'll be back.
Some of the other things you got going on.
Absolutely. So thank you for having me. I feel like I'm in the presence of like celebrity.
It's just the shades, man. It's the shades.
So I think like 2000.
Put your money where your community is. Get in the action. Action 1. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
Action 1, inspiring next.
All right, guys. And we are back. SG2 on Space, episode number 37. This is your host, Shingun. And if I did not mention this, I will mention it now. We are the only weekly space show here in Houston, Texas, possibly the whole state. In any case, here in the Action One Media Studio. So before we went on break, I started out talking about the various 50th year anniversary events for Apollo 11. And, you can find a bunch of this on nasa.gov/special/Apollo 50th/events.html. Then I was talking about Eta Carinae, the gigantic dual binary star system, which has been blasting off pieces into space and probably will go supernova sometime with and new details about it found through ultraviolet image processing, image view, thanks to Hubble imagery. So with that, I want to talk mostly about pulsars in this one because they are a topic which is of great interest to me, and there's been 3 news articles about it this week, which I found quite fascinating. So without going too detailed, actually, you know what? There is a very nice NASA video which basically goes into what pulsars are. So one sentence is pulsar are, according to the dictionary, is a celestial object thought to be a rapidly rotating neutron star that emits regular pulses of radio waves and other electromagnetic radiation at rates of up to 1,000 pulses per second. Okay, wonderful. But let's see what, was actually said. There is sound, right?
A pulsar is a rapidly spinning neutron star, which is the small, incredibly dense remnant of a much more massive star. A teaspoon of matter from a neutron star weighs as much as Mount Everest, and a neutron star is so compact that a ball about 15 miles across contains more matter than our sun. Neutron stars spin between 7 and 40,000 times a minute and form with incredibly strong magnetic fields. Rapid spin and intense magnetic fields drive powerful beams of electromagnetic radiation, including gamma rays. As the pulsar rotates, these beams sweep the sky like a lighthouse. To a distant observer, the pulsar appears to blink on and off. Pulsars slow down as they age, but some of the oldest pulsars spin hundreds of times a second. Each of these millisecond pulsars orbits a normal star. Over time, the impact of gas pulled from the normal star has spun the pulsar up to incredible speeds. This accretion may be the cause of their weaker magnetic fields. Despite this, these pulsars also emit gamma rays.
All right, so that was a really short introduction. One thing it said is that a 15-mile pulsar is basically has more mass than our entire sun, right? Which is fairly ridiculous. 1 teaspoon of it, I believe, or either a tablespoon, has the same mass as that, I think, of like Mount Everest or something, which is ridiculous. All right. So as you can see, this is very densely packed. All right. The question is, the interesting thing is, astronomers actually do not know, and they argue about what might be inside these neutron stars and pulsars. By the way, pulsars are just neutron stars that rotate really fast. Okay, if that wasn't made clear. Okay, and neutron stars, by the way, are formed. I'm not sure if I mentioned that. It's formed at the end of a star's lifetime. A star that's going to be more massive than our sun. Our sun is going to turn into a white dwarf. It's not massive enough to compact in a neutron star. But if it's bigger, but not too big, if it gets too big, if a star is too big, the end of its life would be a black hole, right? But if it's somewhere in between, then it will turn into a neutron star. It will collapse into itself, and everything will be turned into neutrons. Hence why it's called a neutron star. All right. But we actually don't know what's really inside neutron stars because the pressures and temperatures are so immense. We don't currently have the technology to recreate in the lab, right? Thankfully, NASA is trying to learn more about what's inside the neutron stars through something called a neutron star interior composition explorer, short for NICER, which is an X-ray telescope that literally attached onto the International Space Station in 2017. So what have scientists have already discovered? Well, we found that a pulsar and a white dwarf, remember our sun's ultimate fate is a white dwarf, right? A pulsar and a white dwarf can orbit each other more tightly than the moon orbits Earth. Wow. Also, there's a possibility that we can one day use pulsars like GPS beacons to navigate the cosmos without satellites. So, astronomers are also looking for star quakes, basically the stellar equivalent of earthquakes, right? Possibly due to varying rotation rates, and we see how magnetic fields and extreme gravity, somehow affect the radiation around, right? So also other teams are using these pulsars to search for gravitational waves, and so on and so forth. And this map here is the entire sky in X-rays recorded by NASA's Neutron Star Interior Composition Explorer. All right, so its primary science goals is to obviously look at neutron stars and look at other cosmic sources. So this particular map, it may be kind of hard to see. What are all these like? Looks like particles or something going on. Definitely not your plane, because that would just be weird why you would travel like that. But point is, okay, so this map has data from the first 22 months of NICER's science operations, all right? So each arc actually traces X-rays and occasional strikes from energetic particles, which is captured during, when NICER is during the nighttime, all right? So the brightness of each point in the image is actually the result of all these contributions, right? All right. And so why are these arcs that form? Well, NICER often follows the same path between targets. So the arcs converge on these bright spots, which represent NICER's most popular destinations, what NICER is looking at, right? And those are the locations of important X-ray sources, such as pulsars, all right? So, and this is essentially building up a new X-ray image of the whole sky, since NICER's nighttime is sweeping previously unknown sources. All right. So with this, we're going to be able, this telescope will be able to determine the size of neutron stars, and some of which are pulsars, to a precision of 5%, the size of it. All right. And then with knowing the size and knowing the mass, we can figure out what form of matter it actually is. Is it all neutrons? Maybe it's something else, right? So who knows, right? Any case, also NICER is testing the galactic GPS system thing. So it has NICER has a separate thing called the Station Explorer for X-ray timing and navigation technology, short for the very creative acronym SEXTANT, SEXTANT experiment. So it uses a precise timing of pulsar X-ray pulses to autonomously determine NICER's position and speed, which is kind of cool. And whenever, say, this technology becomes mature one day, when we're away from Earth, we're going to use we could use pulsars, which is rapidly rotating neutron stars, as pretty much our GPS beacons, which is pretty wild. So, speaking of not GPS beacons, there's also cases when suddenly you have these sudden bursts of intense radios signals. So, from sources unknown. So, pulsars we know at least to a degree now, We're like, okay, neutron star spins around. All right, yeah, okay, there's a neutron star over there that's spinning. It's going to send us regular beams of signals when basically, when this thing spins, like every time it spins here, say it's going to eject it towards us, right? Something like that, all right? It's going to hit us every X amount of time, right? And we can anticipate that. So it has a periodic nature to it. All right, but there are things called fast radio bursts, FRBs, which are really one of the most most puzzling phenomenon facing astronomers today, because we have no idea what they are. They're basically brief radio bursts from typically really far away, and we don't know why they do that. Like, where does it come from? Like, what is making it? So we have no idea until now. Possibly we're getting more clue. So some astronomers have used the Australian Square Kilometer Array Pathfinder to basically have confirmed the distance to one of these radio bursts, and these radio bursts last for a thousandth of a second. All right, so, and they've discovered this in a galaxy that's located 4 billion light years away. Now, before I go on about how they discovered it, let's just say that we have not known these things for very long. Like, the first FRB, the first fast radio burst, was discovered only in 2007. It was called the Lorimer burst, Lorimer burst. To date, so let's see, 2007, 2019 now, 12 years. In the last 12 years, there's been only 40 events that have been detected, most of which were retrieved from archival data. So it's not like you detected it then, you're looking through data for something else and you discover it, right? So detecting it is really challenging because they only last for a millisecond, which is a thousandth of a second. And then tracing them back to the source, that's even more difficult, right? So, in any case, how did we discover this particular one? Well, these researchers, the Australian Square Kilometer Array Pathfinder researchers, in 2018 did a dedicated search by the arrays. So by array, there's like a bunch of telescopes here, right? Using 36 radio telescope antennas. So the researchers then used the tiny differences in time that it took for the signal to reach the different antennas, all right, in the array to localize the source of the burst, of the pulse. And then from the differences, they were able to determine the burst home galaxy, right? So, yeah, because like say you have two different, located signal receivers here, right? So this one may take, I don't know, just a little bit long. Say it's coming from that direction. So say it's coming from that direction, which is closer to this one, right? So this telescope, say, will receive a little bit, like the time it receives will be before this one by a tiny amount, right? And then just have like 36 of these, and you do some math, and you should be able to figure out, at least pinpoint in what approximate direction there is, right? So they got a position for this FRB 180924 down to 0.1 arc second. Arc second is just a angle. So if you can imagine arc second, 1 degree, right? 1 degree is actually about, I think, about your finger, like right there, 1 degree. All right, that's about 1 degree, the angle wise. So just imagine 1 over 3,600th of that, something like that. So it's pretty small, okay? So they pinpointed to that in a 0.1 arc second, all right? So it doesn't tell astronomers which object it is, but at least it tells us, okay, it's actually in that galaxy over there, right? So, and it's in that location of that galaxy, which is better than anybody else have done so far. So what they discovered is that this FRB was not located in the galaxy's core, all right? So, but rather out in the galactic suburbs. So what could be out there, right? All right. Well, good question. So, now, knowing this is important because it allows astronomers to identify what it could be, right, and what it's not. So, for instance, now we know it's not a supermassive black hole because those are in the middle of the galaxy, and it's not there, right? So, what could it be? Could it be a neutron star or a black hole? Not sure. Who knows? that's why we need more data. Thankfully, there has been more data. FRB 180924, the one I just mentioned, is actually the second one to have been localized. The other signal, there was another signal called FRB 121102. I'm not sure how they come up with these naming schemes, but whatever. That's weird. But anyway, the other signal was also localized, but that one was way easier to do because that one actually repeated itself more than 150 times. All right. So, both of these kinds of signals are pretty rare. Yes, so there are some that repeats for a little while. However, single FRBs like the FRB 180924, it is much more common than the repeating ones. So, so we got to get down to that level of precision, right? Eventually, hopefully, we can figure out what kind of object could it be. Personally, I always go with the view of, you guessed it, aliens. I mean, think about it. Non-repeating sources, not a huge black hole, all right? Okay, where you would naturally think something, emit out. Happens pretty much all over the place, all right? And sometimes repeats, sometimes doesn't. What else could it be, right? I mean, just my mind's like, okay, go look at different astronomical objects, but in the back of my mind, all right, aliens. Because you know why? Because how else are you going to send like a signal across a galaxy? I mean, you got to have something that's highly energetic, right? And it has to have a lot of information packed in a tiny burst. What else would it be? Well, you're going to send out what we call a fast radio burst, but really it's just aliens communicating with each other. And we just happen to have receivers that receive it, we're not even the target audience. We just happen to be in the way. All right, that's my perspective. One theory. Okay, I'm not saying I completely agree with what I just said, but possibility, who knows? If we kind of can't figure it out, that's possible, right? So, all right. So besides these Australians, I was going to say the Chinese, recently in relative terms, have built the largest ground-based radio telescope in the world. So previously, the largest was in Puerto Rico, Arecibo. You guys, for those of you who may know something about this, it's radio telescopes, particularly ones that's not in arrays. So arrayed, like the Australian one, there's a bunch of relatively small ones, all clumped together, right? But you could also have a gigantic big one. So radio telescopes, the bigger you are, the weaker signal you can detect, right? So there's one in Puerto Rico called the Arecibo one, and that one for years was the biggest one. It's just a giant parabolic dish on the ground, right? So it looks like a crater, asteroid crater, except it's symmetrical. All right. So the point of that is you have the radio signals come in, and then it bounces into a focal point in the middle, top. Well, the Chinese have built one that's called that's in China's Guizhou province, and it's called the 500-meter aperture spherical radio telescope, FAST. So it's a 1,600 feet wide telescope, 500 meters, okay? And it achieved first light. That's what you call when a telescope, first detects something. First light in September 2016. One of its main goals is to listen for pulsars and other interstellar radio signals, including, as this Newsweek article said, extraterrestrials, which, as I just mentioned, could be why these fast radio bursts happen, right? Okay, anyways. So that is already pretty cool. I like to add on here that this thing can not only look for neutron stars, like pulsars and fast radio bursts, but it could also detect exoplanets, which is, I don't think it was something that the original researchers have considered. So why is that? Well, it's because this can actually look for exoplanets within 100 light years from Earth, but it has to have magnetic fields. All right. So as you know, Earth, we have a magnetic field. Otherwise, we'll be dead by now. All right. So our magnetic field actually protects the planet from the solar wind. And the solar wind is a stream of charged particles that's pretty much constantly coming towards us from the sun. All right. So if we did not have our magnetic field, our atmosphere would have been stripped away and we would not breathe, and all the radiation would hit us and we'd be dead. All right. So it's reasonable to think that other worlds would be shielded the same way, right? If a world does not have a magnetic field and it's there's a star, no magnetic field, it's probably going to be dead. All right. So what this French and Chinese team said is that they could search for magnetic fields around exoplanets are planets outside our solar system, by looking for an interaction of the solar wind with the magnetosphere. All right, of whatever the stellar. It doesn't. I don't know if you will still call it solar, but the stellar wind. All right, with this planet's magnetosphere. So this interaction should generate radiation. So all the planets, Li, the Chinese researcher, he said, all the planets with magnetic fields in our solar system can be found generating such radiation, which can be measured and studied by radio telescopes. But research on the planet's magnetic fields cannot be realized through optical and infrared astronomical observation. Do the exoplanets have magnetic fields? If they have, they should also generate radiation under the influence of the wind of their parent stars. So if we can confirm that, if we can confirm the presence with the FAST telescope, then we could that will basically be a huge filter for whether it's habitable or not, right? So as noted, it's pretty sure, scientists are pretty sure that planets need to have magnetic fields of its own, magnetosphere, in order to have any chance of having life. Okay, so this is great. This is what I think. Okay, so who knew that a giant radio telescope could also help us possibly detect planets that could possibly have life? Isn't that great? Yeah, science. All right. Speaking of science, I want to also talk about. Well, let's see. Why not? Okay, so I'm a member of the Planetary Society, as some of you know, and recently they launched LightSail 2. So we all talk about stars and da da da. Okay, starlight is also very helpful. I'm not sure about neutron stars. I don't know if they. You know what? I'm gonna have to look at radio waves. Can they? Okay, thought for later research. Can neutron stars power light cells? I don't know. But point is, apparently, LightSail 2 went up with no hitch. All right, and what is that? If you listen to my previous show, you'll realize that this foundation, this nonprofit organization, I should say, called the Planetary Society, which was founded by Carl Sagan and currently led by Bill Nye, the science guy, if he still calls himself that. But essentially, on June 25th, 2019, Planetary Society had a CubeSat named LightSail 2, which lifted off from Kennedy in Florida. And this is a spacecraft that is powered by sunlight. It moves by sunlight. All right. So let me see. Bill can probably explain it better than me. Actually, I could explain it too, but he's more entertaining. So, I shouldn't put myself down like that, but why not? Let's. All right. So Bill and I here basically explains what a light sail is. Essentially, can people hear it? So essentially, while he's blabbing and so on and so forth. Okay, so the fire extinguisher there is, Newton's law, right? Every action has an equal and opposite reaction, sort of, right? So normally that's how our rocket propulsion works, right? You eject something from the back, like I eject like a water hose. Imagine that. You press a water hose, right? Or him using a fire extinguisher. I don't know why he's crying. You propel it, it pushes you back, right? Now, the problem with that is that it's limited, right? So as soon as you use up all the fuel, guess what? You can't move anymore, right? Light cells are different in that, as you can look, you use a power light to push it. Now, you might think to yourself, how is that possible? Because light doesn't have any mass, you know, if you realize that. Okay, light may not have mass, but it does have momentum. And as long as it has a momentum, it can apply a force, okay? So now, granted, each individual light particle, called a photon, has a minuscule amount of force, but our sun generates gazillions of them. I don't know exactly how many, but gazillions per second. All right, totally real number, gazillion. All right, and if you have enough of a sail, think of it as catching a wind, right? Except instead of catching the wind, which are air molecules, you are catching light particles. All right, and it can push you, and the more reflective you make it, you get more force. All right, and if you larger the cell, obviously the more you can capture. And so this light cell is this current mission is just going around the Earth, but eventually we would hope that you could use it to carry a spacecraft with no propulsion, so no engines needed, no rocket fuel, nothing, just a sail, very simple, and you can take it to the stars or to other planets. In fact, as I may have mentioned before, there's a program called Breakthrough Starshot, which wants to send tiny little spacecrafts to Alpha Centauri system in less than 50 years. And the only way we know how to do this is by using this technology, because it can constantly accelerate, right? As long as light pushes it. Now, this one is not that grand. It is just a there's a reason why this guy is shown here. Some random dude. Point here is that everyday normal people funded this project. It wasn't by a university or some big company or NASA. It was people actually donating money. So this is remarkable, these cool missions, if enough people are inspired and donate money, for instance, to Planetary Society, then something like this could happen, right? So they actually have a mission control dashboard which went live, and these updates are transmitted from the space from the craft that's up there right now every few seconds. And it has a text file which contains health and status information. And you can also, this is the ground track, so you can see where it's at. All right, and it's really neat. All right, so with all this information, if you want, as you can look at the data and do whatever you want with it. Right. So, Light Cell 2 also has cameras and took its first pictures, which is kind of interesting. Oh yeah, and then you can see, oh, here's his battery, here's his all that. So, yep, and so you guys can definitely check it out. If you just go to the Planetary Society's website, planetarySociety.org, and then you click on Light Cell, there you go. That's where you're at. So, all right, enough of all this science talk, whatever jazz. I mean, okay, unfortunately, for better or worse, let me take a breather. We're going to take a short break. When we come back, we will talk about astrobiology, or rather, I just want to talk about aliens, because that's really the only reason I'm here, to talk about aliens. So,
Put your money where your community is. Get in the action at weareA1.com.
Man, you still here? Go on and subscribe.
Get into action. Yo, we back at it again, baby.
What?
Get into action.
3.
Get in the action.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
I ain't seen you.
Get in the action.
Tell me what is the deal. Cause I'm calling for you.
Get in the action.
Can you feel that? Yeah. See, I'm calling for for you. Can you feel that? Yeah, yeah. See, I'm calling for you. Can you feel that? Yeah, yeah. See, I'm calling for you. Say how you really feel.
All right, so we are back. You're listening to SG2 on Space, episode number 37. And here at the Actual Media Group studio, as noted, hopefully you're watching us on YouTube, SG2 on Space, or Facebook page at facebook.com/The Shen Show. So I figured I'd take a few minutes and talk about the most important things. All right. Recently, I wish I announced this last time, but it's already passed, World UFO Day. That was on July 2nd. And as the name suggests, if you have any interest in UFOs, which I do, darn it. And I am so bad at this, I do not celebrate it. What the heck is wrong with me? Alright, but anyways. So what exactly is that? Well, so you can imagine it's a day dedicated to unidentified flying objects, alright? The existence of it. So, according to its website, it aims to raise awareness about the existence of UFOs and, with that, intelligent beings from outer space, encouraging people to think about the possibility of us not being alone in the universe. Also, you know, there's a couple of other agendas besides the, you know, overall think big and have an open mind. People who organize these, who's part of the World UFO Day organization, really wants governments to actually declassify their files regarding UFO sightings. Now, some governments have done that. Obviously, there's still stuff going on with our governments that they're still doing, which is still classified. You know, why do we choose this particular date? By the way, was it just purely arbitrary? Well, it turns out no. It is actually the date on which the famous Roswell UFO incident happened, right? So, at least somewhere around there. So, in July 1947, just a quick recap of Roswell. A Project Mogul balloon crashed in the desert. Okay. Here's what the Army, Air Force, back then Air Force was part of the U.S. Army. Here's what they say happened. All right. So, unknown day in July 1947, Project Mogul balloon crashed in the desert near Roswell, New Mexico. This was part of a top secret project by the U.S. Army Air Forces with flying microphones on weather balloons to extreme heights to detect Soviet nuclear test explosions. William Brazel spotted this balloon. The wreckage described it as a large area of bright wreckages made of rubber strips, tinfoil, rather tough paper, and sticks. Then the Army quickly came in to recover the debris and then cover it up. So, you know, and then that's what you know, that's pretty much what they say happened, right? So, now, is that really what happened? Gosh, who knows? I mean, they could say all they want, right? From what I recall, yeah, somebody found it, but it was a material which has some really weird properties, all right? And it couldn't be explained. So people, and there was some other weird stuff. So, I don't know. Maybe it is a cover-up. Who knows? Right? Regardless, you know, the other famous spot is, as you guys probably have known, where the secret might be kept. It might be Area 51, right? Of course, everyone has heard of that. Supposedly the most top secret military. It's true. It was so top secret that the U.S. government didn't admit it that it existed until a few years ago and said, yes, we actually have a military base here, which is kind of dumb in that everybody knew it was there and it's military. I mean, really? Come on, you have all these keep out signs. Okay. Anyways, so it was probably the least secretive classified base in the States, I would say. But point is, nobody, like, you require a lot of top secret clearance to go inside, so nobody really knows what's there. And there's all these warning signs everywhere. But so possibly if any aliens or alien artifacts were discovered from Roswell, ended up there. Now, here's the crazy part. On Facebook, somebody, I don't know who, has decided that we're going to set up a 300K people to storm Area 51 and go see the aliens. So if you guys haven't signed up for this yet and you want to, go join that too. It's a Facebook event, and it's called Storm Area 51. They can't stop all of us. So right now, it has nearly 300,000 confirmed attendees, and there's 324,000 interested. All right. So here's what the event says. We will all meet up at the Area 51 Alien Center tourist attraction and coordinate our entry. If we Naruto run, okay, this is a play on the anime Naruto, right? Where you put your arms behind you and run like that. Really, who runs like that? But seriously, somehow if you do that, you run faster, all right? So if we all Naruto run, we can move faster than the bullets. Let's see them aliens. All right. So so this is clearly a joke, I would hope, because it includes schemes such as throwing rocks. What else? And a Legion nagging, can't speak to your manager, and other jokes basically to get in there. All right. Now the actual facility is infamously guarded by barbed fences, radar, heavily armed military personnel. Has 5,000 square mile desert site, been around for 60 plus years. Officially, it's called the Nevada Test and Training Range, which probably is not what they're doing there. So, Area 51 was established in 1955, but the mystery began somewhere in the 1980s when man claimed to have employed there and saw scientists engineering aliens aircraft, which some believe may have been modeled after the UFO crash in Roswell. All right. Which, by the way, the Army says, like I said, it's an advanced weather balloon, which, some people really don't believe. All right. So, yeah, we shall see what will happen. All right. Can they really stop, like, 300,000 people? Probably. I don't know. We shall see. All right. Before one last thing, I'd like to mention that this is the summertime, right? It turns out that there's more UFO sightings in the summer. Is that crazy? Do you think it is? It is actually not crazy. All right. So, are these extraterrestrials just more active in the summer? The answer is probably no. The answer is probably because we are more active in the summer because the weather's nice. All right. But if you look at the data, according to the National UFO Reporting Center, which is an American nonprofit that collected this, yes. So during June, July, August, September, there's a definite spike during that time period, right? So, in fact, on July 4th, there seems to be like the most, at least here in America. All right. So, what explains that? Well, Cassidy Nicholas is a chief chief archivist for the Mutual UFO Network, or MUFON, an organization that started back in 1969 that looks into reported UFO sightings. So she says, well, people are outside more. They're noticing the weather. They're hiking. They're camping. They're doing outside stuff. Going to concerts. They're looking at fireworks, community gatherings. And they're listening to SG2 on space more. Yeah, like they're going to look up. So there's all that reasons. Add on to that, there's a lot of summer. I don't know why, but typically a bunch of alien movies come out during the summer. Gosh knows why. But so it makes sense. I mean, but look, also during the summertime, at least in certain places, it's just it's easier to see, I suppose. And actually, that may not be true, because it still rains here a lot. But point is, to sum it all up, guys, you know, follow the trend, go outside, enjoy the weather, but don't forget, look up, because you may see something. So with that, I'm gonna have to conclude here. So this has been SG episode number 37 with your host Shen Ge. About exactly right here. And yeah, okay. With that, I will adjourn, but don't ever forget, look up, because you never know what you will see. That's what I plan to do when I'm driving home.
Peace, brother Atum Ra, and you tuned in to Action One Network.